About 4.5 billion kilometers away from our blue home planet is the giant planet Neptune. For many years, it was simply not possible for humans to observe the bluish shimmering celestial body at close range. This was to change in 1989. At that time, NASA sent the space probe Voyager 2 into space, which provided mankind with the first real images of our galactic neighbor. In our contribution today, we would like to take a closer look at Neptune together with you. In doing so, we will also take a look at some breathtaking photos of the celestial body, which will leave you in pure astonishment. If you like our videos, please support us with a thumbs up, subscribe to Simply Space, and look forward to the videos that will be waiting for you in the future. The ice giant Neptune. With an equatorial diameter around 50,000 kilometers, Neptune is becoming the fourth largest planet in our solar system. In terms of its dimensions, Neptune is 4 times larger than the Earth, whose diameter is 12,742 kilometers. The mass of the celestial body is even 17 times greater than the corresponding value of our blue home planet. In detail, Neptune is a so-called ice giant. This category includes those giant planets whose masses consist mainly of water, methane, or ammonia. In our planetary system, there are 2 such ice giants. In addition to Neptune, Uranus is also classified in the corresponding class. Contrary to the first assumption, however, the planetary surface of an ice giant is not necessarily frozen. In fact, the corresponding substances are present as so-called supercritical fluids. That's to say, they're in a special state of aggregation in which the properties of liquids and gases are combined. Discovery and characteristic coloration. The existence of Neptune has been suspected since the early 17th century. Among others, the famous Italian scholar Galileo Galilei succeeded in identifying the planet in the firmament between 1612 and 1613. However, the existence of Neptune was not officially confirmed until 1846, when various calculations and observations scientifically substantiated the existence of the distant planet. Incidentally, the name of the celestial body comes from Roman mythology. In the stories of the ancient Romans, Neptune was considered the ruler of the oceans. In view of the characteristic blue coloring of the planet, which is visually reminiscent of water, the choice of name was extremely appropriate. However, the surface coloration of the celestial body is not caused by a rich water supply, but in reality, by large amounts of methane. The galactic companions of the giant planet. Neptune does not orbit around the Sun alone, but enjoys the galactic company of at least 14 moons. The largest of all Neptune moons is Triton, which has an equatorial diameter of about 2,700 kilometers. The natural satellite of our blue home planet is slightly larger than Triton with a diameter of about 3,474 kilometers. Interesting to note, within the research, it was long suspected that the dwarf planet Pluto is a former moon of Neptune. Later investigations led, however, to the conclusion that this thesis does not correspond to the truth. If you decide to search for Neptune with the naked eye in the starry sky on a clear night, you'll unfortunately have bad luck. This is because the ice giant is the only planet in our solar system that cannot be seen in the firmament without technical aids. Days and years on Neptune. At a distance of about 4.5 billion kilometers, Neptune orbits around the Sun. The orbit of the celestial body describes an almost complete circle. While the Earth only needs 365 days to orbit the fixed star of our planetary system completely, Neptune estimates a much longer period of time for orbiting the Sun. So, it takes almost 165 years before the ice giant has completely orbited the Sun. The days on Neptune are again substantially shorter than on our Earth. According to this, Neptune only needs about 16 hours to rotate once around itself. Just like on our blue home planet, Neptune also has different seasons. While autumn, winter, and the others on Earth last only a few months each, the individual periods on Neptune extend over a period of more than 40 years. The clinking cold planet. Because Neptune is separated from the Sun by such a huge distance, the intensity of solar radiation on the planet is also relatively weak. This fact has a direct effect on the temperatures that prevail on the surface of the ice giant. Thus, the thermometer on Neptune never exceeds the value of -201 degrees Celsius. Due to its material composition, Neptune also has no clearly defined atmosphere. In all probability, however, the planet has a solid, quite large core, which is approximately the size of our Earth. While it's freezing cold in the outer regions of Neptune, temperatures of up to 7,000 degrees Celsius prevail around the planet's core. The exploration of Neptune. In the late 1970s, NASA sent the unmanned spacecraft Voyager 2 into space to study the composition of various planets in our solar system more closely. After the spacecraft had already collected important information about Jupiter and Saturn, it finally reached the immediate vicinity of Neptune in 1989. As mentioned at the beginning, Voyager 2 succeeded in taking the first real photos of the giant planet, which show the celestial body in all its galactic splendor. During the mission, the planet's rings were discovered for the first time, and 9 previously unknown moons of the planet were also discovered. But also, the investigation of the already known and largest Neptune moon Triton was an important goal of the mission. It could be determined that numerous geysers rage on the surface of the moon, which eject liquid nitrogen in large quantities. If you thought that Voyager 2 would stop its service after passing Neptune, you were wrong. In fact, the spacecraft, which left Earth on August 20th, 1977, is still orbiting through the endless expanses of space, from where it still provides scientists on our blue home planet with many important data. In the course of its mission, Voyager 2 produced numerous images of the planet Neptune, which were later supplemented by images of modern telescopes. Let's take a closer look at some of these extraordinary photos. The fine ring system of the giant planet. Some of the official photos show the breathtaking rings of Neptune. On the corresponding photos, especially the 2 main rings, which orbit the planet, can be seen particularly well. The ring system of Neptune is very different from its counterpart in the immediate vicinity of the planet Saturn. While Saturn is surrounded by hundreds of thousands of rings, which together form a complex system, the ring system around Neptune consists of very fine and significantly fewer orbits. The individual Neptune rings are relatively dark and consist mainly of microscopic dust particles. Experts suspect that these galactic dust accumulations are the remnants of various meteorite impacts on the surrounding moons. The small moon Hippocamp. On a photo taken by the Hubble Space Telescope, we recognize the small moon Hippocamp. In detail, it's the smallest of all of Neptune's moons. This natural satellite of the ice giant was discovered in 2013. When Voyager 2 passed the vicinity of Neptune, it could not discover Hippocamp due to its limited technical capabilities. Since the moon is not only extremely small, but also quite dark. On the images published by NASA, we can also see the moons Thalassa, Galatea, Despina, and Larissa. Unique details. Some more photos show Neptune in its full splendor. In the photos, we not only see the characteristic blue coloration of the celestial body, but can also make out numerous details on the surface of the ice giant. According to this, we recognize large cloud formations that cast a clearly visible shadow. Scientists suspect that the clouds on Neptune are largely made up of methane gas. The fact that the appearance of Neptune can vary considerably depending on the angle of the view and the season is shown in the photos, which show the giant planet and its moon Triton as sickle-shaped formations. The surface of the moon Triton. The moon Triton was also closely examined by the highly complex equipment of NASA. The surface of the natural satellite is adorned by numerous geysers, and some craters of meteorite impacts are also clearly visible. Nereid. The moon Nereid is the 3rd largest natural satellite of Neptune. Nereid was first discovered in 1949 by the astronomer Gerard Peter Kuiper. In detail, Nereid was the last moon discovered before Voyager 2 set off in the direction of Neptune and was able to locate several other natural satellites of the giant planet. The space probe of the renowned space agency finally delivered the first images of the Neptune moon, which was named after sea nymphs from Greek mythology. Proteus. If we look at the photos of the moon Proteus, we quickly realize how diverse the natural satellites of Neptune are in terms of their shape and composition. While many of the moons in our planetary system appear to be spherical in shape, Proteus breaks up the familiar pattern with its unusual shape. The existence of the moon, whose name is also borrowed from Greek mythology, was completely unknown to mankind until NASA's Voyager 2 mission. We hope that we could inform you about Neptune in an exciting way with our video. Which photo of the ice giant fascinated you most? Is there a fact about the giant planet that specifically amazed you? Feel free to share your thoughts on this topic in the comments. If you liked our video, show us with a thumbs up. Thanks so much for your active interest. Take care, and see you next time.